Bismillahirrahmanirrahim. Assalamu alaikum dear students. I'm Arif and I welcome you all in today's session. Well, to access the notebook for today's session, you can access the course page on my personal website arifbhat.me. You can click the appropriate link under the lecture resource column to view it in NB viewer and run it online in Binder. The other way is to download the notebook file from the course GitHub account Arif PUCIT. And all the notebooks for this course are hosted in the public data science repository data science over here. Well, this is the Jupyter notebook dashboard running on my local machine at port 8888, and here is the notebook for today's session. Lecture number 3.1 of the third module, Python Programming for Data Scientists, for the course titled Tools and Techniques for Data Science. Well, this is the first session of this module, and today we are going to talk about NumPy. Well, my dear students, data analysis typically refers to numerical data. For example, stock prices, sales figures, sports scores, sensor measurements, and so on. And this NumPy, numerical Python, is the fundamental library for scientific computing and is centered around a powerful n-dimensional array object. For the next few sessions, we will do a scuba diving into the details of this data structure and its usage. We will see and understand a variety of methods for creating NumPy arrays. We will do a comparison between Python list, Python built-in array module, and NumPy arrays. We will see the power of NumPy array while performing various arithmetic, statistical, and linear algebra operations. We will also practically understand searching, sorting, counting, copying, stacking, and broadcasting NumPy arrays. And today's session is the first on this NumPy library, and today we are going to talk about the creation of NumPy array. And here is the agenda of today's notebook. So first of all, we will see some details about this NumPy array object, and we'll see how we can create NumPy arrays using the default array constructor. And then we will talk about this plethora of NumPy array creation functions like zeros, ones, empty, full, I, and so on. So let's start playing. My dear students, a NumPy array is a numerically ordered sequence of elements stored contiguously in memory that can store elements of homogeneous types, usually numbers, but can be booleans, strings, or other objects as well. It is iterable, mutable, non-growable, and shrinkable, unlike list, and it allows duplicate elements. I have described a 1D, 2D, and 3D NumPy array over here. Let's talk some of the attributes. Let's consider this 1D NumPy array. First of all, the dimensions. ndim is an attribute of NumPy array that contains the dimensions. Over here you see this is a 1D array, and the ndim has 1. This is a 2D array, so ndim attribute will have 2. And this is a 3D array, so the ndim attribute has a value of 3. Similarly, other related characteristics of every NumPy array is the axis. For a 1D array, we have just axis 0. This is a vertical axis that goes from top to bottom, and this represents the number of rows. So 1, 2, 3, 4, 5. So we have 5 rows. In case of a 2D array, we have two axes, axis 0 and axis 1. Axis 0, as usual, is the vertical axis, goes from top to bottom, and this axis 1 is the horizontal axis that goes from left to right, and this represents the number of columns 1, 2, 3, 4. And similarly, in case of a 3D array, we have axis 0, axis 1 and axis 2, and this axis 2 is actually the number of columns along the z-axis. Another term is the rank of this array. This is actually the number of axes. Over here we have a rank of 1. This array has a rank of 2. This array has a rank of 3. And the shape of every array is a tuple. In case of 1D array, you see it has a shape of 5. Over here we have 5, 4. 5 rows, 4 columns. And over here we have 5 rows, 4 columns, and then we have 3 levels. Well, size is another attribute, which is actually the total number of elements. Over here we have 5 elements, and over here we have 5 into 4, 20 elements, and over here we have 5 into 4 into 3, that is 60 elements. So the size of an array are the total number of elements in that array. And item size is actually the size of each element in bytes. And this n bytes attribute is the total number of bytes that are occupied by a NumPy array. Okay. So my dear students, unlike other modules that we have been working on so far, we have to download and install NumPy. And to do that in Jupyter Notebook, you can use this command. You need to import the sys module and execute this command, pip install NumPy. In most of the cases, if you have used Anaconda, this is pre-installed in case of Anaconda. And right now the version I'm using is 1.19.5, and this is the path. Okay, so let's talk about the default constructor that we get with the NumPy. So this is the constructor array, and we pass it the only one required argument, and that is the sequence from which we want to create the array. The optional argument is the data type that specifies the type of the array objects, and this D type can take these values: signed integers, unsigned integers, float, complex, and others. You can check out all the supported NumPy types by using its attribute sctypes. So the default is normally int64 for integers and float64 for the float numbers. Okay, we can create an empty NumPy array. So you see we called the array constructor and passed it an empty list. So it has created a NumPy array, an empty array. You can create a 0-dimensional array, although it is not of much use, having no axes at all. So 1D array, yes. My dear students, if you want to create a 1D array, you just need to pass a sequence. Over here I'm passing a list to this constructor, and I'm also passing the D type, which is uint16. So that means every element over here will occupy 2 bytes, 16 bits. And if I do not pass this, the default is int64. Okay, so you can always access all the attributes, the dimension, shape, size, and D type. Let me run it and show it to you. You see the shape of this is 5. The size is again 5. Data type is uint16. Every item is taking 2 bytes or 16 bits. And the total size of this array is 10. Fine. I hope this makes sense. Let's map this onto the 2-dimensional array as well. So I have created a 2-dimensional list having 5 rows and 4 columns. Pass that list to this array constructor, and here we go. So these are the attributes: the dimension, shape, size, and so on. Note the shape is 5, 4. And you can always create 3-dimensional arrays. Over here I have created a a three-dimensional array having 5 rows, 4 columns, and 3 levels. And remember, in case of a 3D array, we have 3 axes. You need to understand this is axis 0 that moves from top to bottom, represents the number of rows. This is axis 1, moves from left to right, normally represent the number of columns. And this is axis 2 along the z-axis that represents the level of this array. Okay, I hope this makes sense. Anyway, so there are a number of different array creation functions that we are going to talk about today. For details, you can visit the official documentation. The first method I'm going to talk about is np.zeros. My dear students, this zeros is a method to which you are going to pass the shape. This is the only required arguments. This is going to create a 3 by 3 array filled with floating point zeros, because the default data type it takes is float. So in case if I just pass 3, so it will create a one-dimensional array having 3 elements. Note the dot with this 0. This shows that this is a float type. And over here we have a 2 by 3 array. And if you want to change the D type, the default type is float. You want to change that, you can always change that by mentioning this argument D type to np.int16 or whatever you think feasible for your application. After zeros, we have another similar method, that is ones. My dear students, this is very similar to zeros. The only difference is it is going to populate the array with the floating point ones instead of floating point zeros. So you just pass the shape of the array and it is going to create that array for you. So this is a 1D array of 3 elements, a 2D array having 2 rows and 3 columns, and over here I have mentioned the data type. So this time the data type is int16. So zeros for creating a NP array of zeros, and ones for, of course, ones. Then we have another method, that is empty. This is also going to be passed the shape of the array you want to create, and it is going to populate it with the junk values. So let me do that. So let me run it again. This one, you see the values are changing. So empty is going to create a NumPy array with junk values. Okay, so we have np.full. So this is also quite similar, but it is also passed a second argument other than the shape, and that is the default value with which you want to fill in the array. So you pass the first argument, that is the shape, and the second argument, which is the value. So we have a 1D array of 7 elements populated with the value of 54, and this time it will be populated with a value of 21.5. And over here we are passing a tuple, so we are creating a 2 by 3 matrix populated with the value of 21.5. I hope this makes sense. Simple. Then we have the I method. Well, my dear students, if you see in this figure, the I method is used to create a matrix in which the diagonal elements are 1 while the rest are zeros. Remember, once again, the default type is float. If it is passed only one argument, that is this 3, so it is going to create a 3 by 3 matrix, and it is going to have a diagonal values of 1. So if you just passed one argument, so it is going to create a 3 by 3 matrix. If I do it something like this, 3, 3, so this will not have much impact. Okay, so over here 4 by 3, I am creating a 4 by 3 matrix. Note the position of the diagonal this time. It is again moving like this, and this k argument is going to tell you where this diagonal 1 should come. By default it is 0, so it will start from this location. If you give it a value of +1, it will start from here. If you give it a value of -1, it will start from here like this. So let's see this over here. I am giving it a value of 1, a 4×3 matrix, and you see this time the diagonal is one position up, and in this case the diagonal is one position down. Okay, so these methods are very useful in linear algebra operations. Once we will be doing the LA module, we will make use of all these methods very extensively. Anyway, the other method is from string. So this method is used to create an array initialized from a text data in a string. For example, if you see this figure, 2, 4, 6, so it is going to create an array having 3 elements, 2, 4, and 6. So the second argument is d type, and the third argument is the separator. The default value of the separator is space. So over here, if you see, I'm calling this from string function and passing it a string having space separated 4 values. So it's going to create a NumPy array having 4 values. I can of course change the d type to whatever suits the application needs. And if the string is separated by commas, you can mention the separator as comma over here. Well, remember, my dear students, in case if your string doesn't have a valid number, you will get an error. So this str is not valid, so it is giving you a deprecation warning. Okay. Then we have the arange method. This arange method, as shown over here, it is going to give you evenly spaced values within this interval from 5 to 9, 5, 6, 7, 8. 9 is not inclusive. Remember, it can pass 3 arguments: the start, the stop, and the step. The default value of the step is 1, and if you do not provide start, you just provide the stop argument, it will generate value from 0 to stop, not inclusive. So I have given it 5, so it will generate an array from 0 to 4. Great. And we can always change the type. So it is now a float type. I have mentioned 5 to 10. So start is 5, stop is 10. So 5 to 9. Great. I can give the step. Over here I have given 2. So 5, 6 is skipped, 7, 8 is skipped, and then 9. And you can give a minus negative value as a step as well. But in that case, just keep in mind the start value should be larger than the ending value. And we can have a floating point value as a step as well. And over here as well. So I hope this makes sense. This arange method is used to generate a 1D array by mentioning the start, stop, and the step values. And the default data type of the elements that you generate using arange is integer, int64, and of course you can change that. After arange we have linspace. Well, this linspace method actually returns an array. By default it returns an array of 50 evenly spaced elements, but over here in this case the start value is 2, the stop value is 3. So, and we have given the third argument, that is num is equal to 4. So it will generate 4 equally spaced values from 2 to 3, both inclusive. Remember, this time this 3 is inclusive. Okay, so from 2 to 3, 4 values, 1, 2, 3, and 4. So over here we have just given one argument. This is 1, this is the starting value, and this is the ending value. We have not given the total number of arguments. Num is equal to 50. We have not mentioned it over here, as we have mentioned 4 over here. So it has generated an array of 4 elements. But if we omit the third argument, it will generate 50 elements, an array of 50 elements by default, in between 1 and 5. So if I say 1 and 2, So it will generate 50 values between 1 and 2. Hope this makes sense. And over here, -1 to -5, this will generate 50 elements between -1 and -5, evenly spaced elements. So that is why it is named as linspace. Okay, so then we have the rand method. This rand method actually generates an array of random floats between 0 and 1. If you do not pass any argument to random, it will just generate a single value between 0 and 1. Let me run it again and again. So you see, it is generating a random value from 0 and 1. And if I pass it an argument, let's suppose 5, so that means it is going to generate 5 elements. And of course, between 0 and 1. 1, 2, 3, 4, and 5. And if you want to generate values from instead of 0 and 1, you want to generate them from some specific value, you can multiply that with that value. So in this case, it will generate values from 0 to 10. So we have 7 point something, 0 0.9, 0 0.7, 9 point something, 3 point something. Let me run it again and again and again. Hope this makes sense. In case you want to generate a 2D array using this rand function, you just pass it 2 arguments. Over here I have passed it 4 and 3. So we will get a 4 by 3 matrix having values between 0 and 1, of course. And if you want the values to be between, let's suppose, 0 and 10, you can multiply it with 10. And here you go. And similarly, you can, of course, create a 3D matrix using this rand method. Okay, so I hope this rand method is clear. That is used to generate random numbers between 0 and 1. You can create a scalar value. You can create a 1D array. You can create a 1D array within specific range instead of 0 and 1. And you can create a 2D as well as 3D array. Okay, then we have rand int. This method actually returns an array of specified shape. Let's suppose that I call this, so it will generate our random value. So this time it is an integer. So we have 3 arguments: low, high, and size. If I pass low is equal to 5 and high is equal to 20, so it will generate a 1D array from 5 to 19. Remember, in this case, this 20 is not inclusive, and they are, of course, integer. Okay, so probably I have said something wrong. Remember, this will return a scalar value. Once again, if you pass a low 5 and high 20, it will generate a scalar value. And if you want to generate an array, you have to use the size argument. And over here, we are generating a scalar value from -5 to 5. Let me run it again and again. -3, 1, 4, 3, -2, 1, and so on. And this size argument is going to create a 1D array. So now we are going to create a 1D array of size 6. And the low value is 1 and the high value is 101. So great, let me run it again and again and again. And I have just changed the values from -5 to 5. And from 1 to 10, this time I have given a tuple for the size. So it is going to create a 3 by 3 matrix. You see? And if I continue running it, it will generate a random number, random integers for this array of size 3 by 3. Great. And of course, you can create an array of 3 dimensions as well. So this is a 3-dimensional array having 2 rows and 3 columns and 4 levels. Okay, so one more method, that is zeros like. This zeros like method, as apparent from the figure, is going to take an array and it is going to create a similar shaped array but populated with zeros. So this is what is shown over here. This is an array having 0, 1, 2, 3, 2D array, and I have passed this array to zeros like function, and it is going to generate the similar shaped array but populated with zeros. I hope this makes sense. And I'm not going very fast. Okay, and once again, the way we can create a 2D array, we can create a 1D array as well, and 3D arrays as well. Okay, so right, my dear students, that is all for today's session. We will inshallah continue our journey to learn Python programming for data scientists in our next session. I hope today's session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best. Happy learning and Allah Hafiz.